Welcome to Study Loop.
So we want to find maximum volume of a rectangular prism. So what we have is that x squared plus y squared plus z squared equals 4r squared. The box's volume is given by v equals xyz. And we want to find the maximum of the function, of the volume function that is, and we have this condition right here. So what we can do is express z as an equation. So we solve for z and get that z is equal to the square root of 4r squared minus x squared minus y squared. And then we'll use the standard method. We will have our partial derivatives set equal to 0. So we have our partial derivative with respect to x is y times 4r squared minus 2x squared minus x squared, minus y squared actually, over the square root of 4r squared minus 2y squared minus x squared equals 0. Then we'll get something very similar for our partial derivative of y equation. We're just going to kind of switch the values around. So this is the partial derivative of y. This becomes an x. This becomes a y. This becomes an x. And then the denominator, just to confirm, this is not a 2 down here. So we have minus y squared minus x squared. And the same thing down here, just minus x squared minus y squared. Set that equals 0. Since we know the denominator cannot be 0, we were going to set this numerator equal to 0 and this numerator equal to 0. What that's going to end up giving us is x equals 2r over root 3. And if we substitute this value into one of our equations, we get that y equals 2r over root 3 as well. Then we can substitute this in further, and we get that z equals 2r over root 3. So there is an absolute maximum of the function, and it's going to occur when x equals y equals z equals 2r over root 3, and that maximum volume is going to be 2r over root 3 cubed, which is equal to 8r cubed over 3 root 3. Final answer.